Hi guys, this is the video for chapter 11, lesson 4. I'm going to break this lesson up into two parts. So today's video is over part 1. So in this lesson, we are taking a look at finding the area of a polygon, a regular polygon. And so let's talk about a regular polygon for a second. So a regular polygon, we've looked at these before, but really it's just a polygon where it has all the same angles and all the same sides. So if I drew a shape like this, a pentagon here with 5 sides, if I called this a regular pentagon, then what that means, this word regular means it has all 5 of the same sides, and then it has all 5 of the same angles. So up until this point, we've looked at finding the area of a circle, a triangle, quadrilateral. Well, now we're going to take a look at finding a regular polygon. And a regular polygon can have many different sides. You could have a regular octagon, you could have a regular hexagon, right? As long as it's regular, that's the type of shape we're looking at. So if I were to say this middle section going from the middle to one of the sides, so like that, that was 4. And then I were to say this section here was 6, then would you be able to kind of break this polygon up into shapes to find the area? Would you be able to do that? So you can pause and kind of think through this for a second. Could I break this up into some shapes and find the area? Well, I probably could break it up into triangles. If I broke it up into triangles, I think I would have, let's see, I know my drawing's not perfect, but if every single side was congruent, so like this would be, this side is 6, and this side is 6, and this side, I'm drawing it upside down for some reason, is 6, and this side is 6, and then from the center to the, and I'm going to put a little right angle here, from the center to the side, it's 4 for every single triangle. I know the triangles don't look like they're exactly the same. Then we could probably count out how many triangles there are and multiply that, find the area of one triangle, multiply that by however many triangles there are. So if I were to look at this and kind of, shade in my triangles, I have 1 here, 2, 3, 4, 5. Okay, so what I realize is however many sides I have, that's how many triangles I'm going to have. So to find the area, I could probably just find area, let's say, area of one triangle. That would be 1/2 times 4 times 6, right? And so if I can do that, 1/2 times 4 times 6, whatever 1 is, I just multiply that by 5 and I get the whole area. So 4 times, or half of 4 is 2, 2 times 6 is 12. And so this is 12 units squared. And then to find 5 triangles, I could just do 12 times 5 and I get 60. So the area would be 60 units squared. Okay. So when we're looking at this, it seems like this little height right here from the height of the triangle, this from the center to the other side there, that little segment is very important. And so is this side, right? This base of the triangle is also very important. So if we don't have these two things, we might be stuck a little bit. And so let me classify these with names. Let's give them a name. What we call this height of the triangle, really it's from the center to the opposite side, making a right angle, that is called an apothem, okay? So it has a special name, apothem, okay? And this base, it doesn't have a special name because it's just like the side of one of the sides of the regular polygon. But if I were to find all the sides of the polygon, then that would be the perimeter, right? All sides equal the perimeter. So what I realize is, instead of having to split up this equation into two parts and say, step 1, find the area of the triangle. Step 2, multiply it by 5. What I realized is I could probably combine these two equations and just say 1/2 times the height of the triangle, so the apothem. So let's call that the apothem. So 4 would be the apothem. 1/2 times the apothem. And then at times 6, then whatever this is times 5. So really I'm doing 6 times 5. That's the perimeter. So 1/2 times the apothem times the perimeter gets me the entire area of the shape, okay? So what I realized is this actually helps me just do it all in one go rather than having to like break everything up. And so if I were given a picture like this, let's imagine we didn't use these equations. Just remember that our answer was 60 units squared for the area. Let's just double check to see if we'll get the same thing. So if I knew that one side is 6 and there's 5 sides, I know the perimeter has to be 6 times 5. So let's do 1/2 times the apothem, which is 4, times 6 times 5, okay? Multiply it all out. 1/2 of 4 is 2. 2 times 6 times 5 is 30. 6 times 5 is 30. And then 2 times 30 is 60. So I get the same exact answer. And I just had to do one equation rather than split it all up. Now, if you feel like it's more concrete in your brain, where you feel like when you split it up, it makes more sense, go ahead and do that. That's fine. But if you just remember 1/2 times the apothem times the perimeter for finding the area of a regular polygon, then you can just do it all in one go rather than do two equations. Okay. So let's talk about a little dilemma. And I'm going to actually reiterate some of these notes. I'm giving you this note page in class. And so if you don't have it, just watch and you can even copy some of this down in your notebook and take some notes over it. But I don't have this uploaded on RenWeb. So this is a little practice to get us ready. An apothem is a segment drawn from the center of the polygon, perpendicular, has to be perpendicular to the other side. Okay, so down here is a picture that kind of shows that. And here's a little shape, a regular polygon. There's the apothem. What angle is that? That's 90 degrees, perpendicular angle. So that's the definition of an apothem. And so to find the area of a regular polygon, it's area equals 1/2 times apothem times perimeter. And so apothem A equals the apothem, P equals the perimeter. And for a regular polygon, all sides are congruent and all angles are congruent. So they're all the same, okay? So here's the problem. What if we are given the perimeter, but we don't have the apothem? So that's really our main focus for today, is saying, well, okay, yeah, I know I could just do 1/2 times A times P, but if I don't have part of this information, I can't plug it into my equation. So likewise, if you were to create a triangle, you don't know the height of this triangle, so you can't keep going. So we're going to talk about how to find the apothem if we're given the perimeter, and we're going to talk about how to find the perimeter if we're only given the apothem, okay? So this brings us back some trig functions we're going to use. And so remember, we have SOH, CAH, TOA for sine, cosine, and tangent. And these are ratios where sine of an angle X, let's say, equals opposite over hypotenuse. Cosine of an angle equals adjacent over hypotenuse, and tangent of an angle equals opposite over adjacent. So this SOHCAH-TOA helps us remember the ratios: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So we're going to practice that a little bit. Okay, so here's the setup. If I don't know this apothem, this height, I am going to use my knowledge of a full circle and divide that by however many sides I have to find the angle. So if I split this all up into 5 triangles, that means each angle would be 360 divided by 5. And so 360 divided by 5 is 72. That means each angle is 72 degrees. Now, if I am looking at this as a right triangle, because I can only use my trig functions using a right triangle. If I know that the perimeter is 60, that means one side would be 60 divided by 5 is 12. One side would have to be 12. Okay, so if I were to split this angle in half, or this triangle in half, that means it would be 72 divided by 2. Okay, so this angle and half of the angle, half of that is 36 degrees. Okay, so that means I'm going to bring this picture out here. Okay, that means I have a right triangle. This is the apothem. I don't know what it is. This is 36 degrees. And then this side would be half of 12, right? So if this whole thing is 12 and this whole thing is 12, that means half of it would be 6. Okay, so if I have one side and one angle, that's all I need to use my trig function. So remember, the angle is my reference point. So we're going to decide which trig function are we going to use. If we have this side opposite is opposite of the angle, so this is O, and this is what we call the this is the hypotenuse, and this is adjacent, right? So OA spells out TOA. So we're going to say tangent of 36 equals 6 over A. And we're going to solve for A here, okay? So in order to solve for A, we have to multiply A by both sides so that it's not in the numerator. And then we have to divide by the tangent of 36 because we want to get A by itself. Okay, so to get A by itself, we have to first get rid of it being in the denominator. Sorry, did I say numerator? Get rid of it being in the denominator, and then we have to multiply it by on both sides, and then we're going to divide by tangent. So this cancels, and what we have left is 6 divided by tangent of 36. And so you're just going to plug that in. 6 divided by tangent of 36, which ends up being a decimal, and it's going to be about 10.4. Okay, if I round it, 10.392. So 10.4. Okay, that's the apothem. All right, now that you have the apothem, you can plug the rest of the information into your equation and find the area. So if I wanted to find the area now, I could just say area equals 1/2 times 10.4 times the perimeter, which is 60, and that was given to us. Okay. 10.4 times 60 times 1/2. So the area is about 312 units squared. And I didn't give you the units on this one. So units squared. Okay, so let's try another one. Let's try another one where, again, we need to find the apothem. So if you want to write out some steps in your notes, you're more than welcome to. So step 1, find angle of a right triangle. Okay, so I'm gonna create a right triangle using this right here, and I need to find this angle. So really it's just 360 divided by however many sides, and then divide it again. So you could say 360 divided by the double amount of sides. So if there's 6 sides, we're going to do divide by 12. Okay, so 360 divided by 12 is 30 degrees. Okay, so you could do 360 divide by number of sides times 2. Okay, so I'm going to put this in parentheses. 360 divided by number of sides times 2. Okay, so that's 30 degrees here. Okay, now we are going to find what the base of this right triangle would be. And so this is 30 degrees. The base would be 5 because it's just half of 10. And now we can use the trig function. So step 2, given angle and base of the right triangle, use trig functions to find the apothem or the missing side. Okay, so what we're going to do here is basically we have 30 degrees, opposite is the 5, adjacent is what we're looking for. So OA, tangent again, tangent of 30 equals 5 over A. So we're going to multiply both sides by A. And then we have to divide everything by tangent of 30. So then we have A equals 5 divided by the tangent of 30. And you're just going to plug that in. So 5 divided by the tangent of 30 is about 8.66. So about 8.7. And so now to find the area is just 1/2 times the apothem times the perimeter. So the perimeter is 10 times 6. So 60, right? Again, 16, right? Times 2.7 times 1/2. And the area is 261 units squared. Ooh, there you go. Okay, let's do a few more of these. And then that's all I'm going to have us do today is just figuring out how to find the area. It's a lot. There's a lot of steps. So step 1, find the angle of the right triangle. So again, we're going to find the angle of the right triangle. And again, we have a hexagon. So there's 6 sides. So we're going to do 360 divided by 12 to find this little sliver. And that is 30 degrees. Now, this is interesting because you have a 30-degree angle, which means if this is a right angle and this is 30, how many degrees would this have to be? This is a 30, 60, 90, okay? And if the height is 5 times square root of 3, well, we know, I'm going to draw a 30, 60, 90, that it's x, hypotenuse is 2x, and this is x times square root of 3. So if I know that the height here is 5 times square root of 3. That means this base has to be 5 times square root of 3 divided by square root of 3, which is just this number, 5. So I actually can use the patterns of my 30, 60, 90s to actually help me find stuff if I see a correlation between the special triangles. So right here, I have that this is 5, which means the whole entire thing is 10. And so now I can find the perimeter, and I already have the apothem. So this time they gave me the apothem and I need to find the perimeter. So the perimeter is, again, 60. I keep having perimeters with 60. That's not normal. Anyway, so it's area equals 1/2 times the apothem, which is 5 times square root of 3, times the perimeter, which is 60. So we can plug that in. And the answer is about 259.8. This one has the unit centimeters squared. Okay, let's look at number 4. So number 4, we've got a square and we need to find the area. Well, if this is a square, if it's a regular like square, can't we just do 15 times 15? Yes, you can. 15 times 15. That is what, 225 meters squared. Okay, we're done. However, I want to double check to make sure that we can use this method to still find the same thing. So we're gonna just practice this a little bit and see if we get the right thing, okay? So this angle would have to be 360 divided by 4 and then divided by 2. So that would be divided by 8, right? Because it's 4 sides, double that is 8. So 360 divided by 8 is 45 degrees. Well, here's another special right triangle. This is 45, this is 45. So if this is 15, then half of it is 7.5. And then for a special right triangle, isn't it x rad 2? The hypotenuse is x rad 2. So if these are 45 degrees, then that means it's 7.5, 7.5. So the apothem is 7.5. So 1/2 times 7.5, I didn't even have to use trig for that one, times 15 times 4. 15 times 4 is, oh, wow, 60 meters for the perimeter. Again, I did not anticipate to have so many same perimeters. And when I multiply this all out, I get 225 meters. Surprising, huh? Okay, so that is the answer. Now, the tricky part really is being able to use the trig functions. So let's just do one more so I can practice using trig with you guys. We'll do number 1. And notice on your study guide, there's just not enough room for you to write everything down. And so I need you, please, to get out a piece of paper and write on a piece of paper. So I'll draw this picture up on the board here. You have a triangle, regular triangle, and the base of the triangle is 14, but we don't have, so this is 14, but we don't have the apothem. And we don't have the height, right? So this is the apothem. So we need to find this angle. So step 1 is to find that angle. And so that would be 360 divided by 6, because it's the number of sides times 2. So 360 divided by 6, which is 60 degrees. All right, interesting, because we have a 30, 60, 90. So you can just keep using trig if you want to. So this is 60 degrees, that means this is 30, and this is, if we want to just find half of that side, 14 divided by 2, this would be 7. So let's practice using a trig function to do this. So we have a right triangle where this is 7, this is 60, and we need to find the apothem. Okay, so opposite is here and adjacent is here, so that's going to be OA, OA. So tangent of 60 equals 7 over adjacent. Again, we're going to do multiply both sides by A, and then we're going to have A equals 7 divided by tangent of 60. Okay, so 7 divided by tangent of 60 equals about 4.04. Okay, now you have your adjacent, your apothem. Now we can do 1/2 times the apothem, 4.04, times the perimeter, which is 14 times 3. So 14 times 3 times 4.04 and divided by 2 or multiplied by 1/2. That's about 84.84. So 84.8 meters squared is the answer. Okay, hopefully that made sense. I am putting up another video of another teacher teaching this. It's the exact same thing, but that way you can see someone else do it if you need to. But that's all I have. So that's all we're going to do today. There's definitely another side to the study guide that we will finish up another time, and I'll make another video for that.